and welcome. My name is Ashish Ahuja. I'm an applications engineer with Texas Instruments. I'm really excited to introduce you to the brand new Tiva C-Series TM4C129X family of ARM Cortex M4 microcontrollers for applications that connect, communicate, and control. In this video, we will briefly review the guidelines for improved ESD performance on TM4C129X microcontrollers. We will discuss the basic ESD models and review some guidelines and considerations for improved ESD performance. We will look at the human body model, charge device model, and system level ESD. The human body model is typically rated for 2000 volts and it simulates an ESD event when a person charged with either a positive or a negative potential touches an IC pin at another potential. JEDEC test method JESD22-A114F is used to test ESD sensitivity for human body model. On the other hand, charge device model is typically rated for 500 volts and it simulates a device getting electrically charged and then abruptly getting discharged to a grounded surface. JEDEC test method ESD22-C101C is used to test ESD sensitivity for charge device model. The TM4C129X devices are tested for compliance with human body model for up to 2 kV and charge device model for 500 volts. It is imperative that we understand that the two JTEC standards we just discussed are used to test ESD sensitivity at the device level. In order to test the ESD sensitivity at the system level, other standards such as IEC 61000-4-2 are used. Speaking about IEC 61004-2, specifically, it simulates a charged person discharging through a metallic tool such as a screwdriver into or close to an electronic system. The IEC ESD testing is very system dependent and therefore it is usually performed by customers on their own end systems. Next, I'd like to share some system design guidelines with you for improved ESD performance. To make the discussion easier, we can group the guidelines in 3 categories. Guidelines for layout and PCB design, considerations for external connectors, and consideration for enclosures. Let us briefly talk about the layout and routing first. As much as possible, try to minimize the loops and ground planes to reduce possibility of inductive coupling. Providing return paths or continuous ground planes is recommended whenever feasible. It is also recommended to separate power domains by providing isolations between MCU and switching power supplies using components such as ferrite beads, common anode chokes, etc. Whenever possible, physical isolation can be provided by separating power domains in different layers. You can use decoupling caps to improve the ESD performance, but you should keep in mind that they are more effective when placed in close proximity of the microcontroller pins. This is illustrated in the figure shown on the screen. Most real-end products have connectors such as RJ45, USB, DB9, or simply pin headers. The exposed terminals of these connectors provide a conductive path for electrostatic discharges to happen. To prevent damage to the sensitive active components due to ESD, it is recommended to use protective clamping devices or RC networks. While choosing the clamps, please keep in mind that the clamp should be activated as quickly as possible and route as much current away from the device as possible. Clamps are most effective when they are placed as close to exposed terminals as possible. In addition to that, you can also use a series resistor or a RC network in combination with an ESD clamping device for vulnerable connectors. Lastly, the electrostatic discharges can also propagate to the active components through holes or etc. in a poorly designed chassis or enclosure. In such cases, it is a good idea to provide adequate grounding such that the static charges are routed away from the critical semiconductor components. As a general guideline, if possible, use shielded cables for connections between 2 enclosures. Some suggestions for routing static charges away from the active circuitry are illustrated on the diagrams on the screen. Please take a moment to review them. In some applications, simple things such as grounding the external connector to the chassis can considerably improve the overall ESD performance because it allows some of the energy from the ESD strike to dissipate directly to the case and not reach the main PCB. You can also minimize the case openings or number of holes in the product enclosures to prevent the ESD strikes from reaching the active circuitry. Take a look at the diagrams on the screen to get a better idea of this. I know that's a lot of information to keep in mind. To make it easier for you, Tiva C-Series system design experts have authored an application note that provides in-depth system guidelines for systems involving TM4C129X devices. The application note is available online on www.ti.com/tiva-c. Go to the Technical Documents tab to download your copy right now. So today, we briefly discussed some guidelines and considerations for improved ESD performance using TM4C129X microcontrollers. Do take a look at the System Design Guidelines application note that I referenced during this video. Should you need more information, please visit the links shown on the next screen. We will be back with more innovative products. Till then, have fun with TM4C129X devices. Bye.